Hi, and welcome to question 4 of the Leaving Cert Ordinary Level 2025 Paper 1. So getting straight in, I don't have the marks scheme's not out yet, but part A says solve the following equation in A is an element of R. It just means your A value can be any number. Could be a fraction, could be a decimal, could be a whole number, could be a negative number, it could be any number, effectively. Now we look at it straight away, it's pretty straightforward. I see brackets, so I'm going to remove them. Okay. This is an equation of one unknown, so it is solvable. And I remove the brackets by multiplication. 5 times a is 5a. 5 times negative 3 plus by minus is minus. 5 threes is 15. Okay, so now I have a slightly simpler statement. But to solve something, I want the a values to be all on one side and the numbers all on the other. So this minus 15, I'm going to get rid of it. I'm going to get rid of it by doing the opposite, and I'm going to add 15 to it. If I do that on one side, I have to do it on the other. Okay, that creates a few little issues. I have to just do this little calculation here. Okay, the minus 15, the plus 15 will cancel each other out, and I'm left with 5a. The 7 and the 15 on the right hand side will combine to give 22. Now I'm going to try get rid of the 2a on the right hand side. Okay, and I'm doing that by taking 2a away from it. If I do it to one side, I have to do it to everything on the far side. That has the consequence then of getting rid of the a's on the right hand side, but on the left hand side I now have created a little bit problem. 5 is something, take away 2 is something, is 3 is something. Now you might be able to guess here to a certain extent, but it's a little bit tricky. 3 times some number gives 22. Now it's not 7, 3 sevens is 21, 3 eighths is 24, so it's not a whole number, our answer. I'm going to find out what it is by getting rid of that 3. I'm going to divide by 3 on the left hand side. If I do something to the left, I have to do the same thing to the right. Okay, and that gives me an answer of a is equal to 22 over 3, which is a real number, but it's just not a whole number. Okay, and that's the answer. Now, part B here is it's differentiation. Okay, the differentiation is a very powerful tool, and it's one that can be undersold. But in terms of human civilization, or science or maths, it is probably one of the most powerful tools we have for looking at change. And that's all slope is. Slope is a way of measuring the rate of change of something. Okay, and it's going to be very easy with a linear model, less easy with something like this, which is a third order polynomial, or classically called a cubic equation. It has a specific kind of shape. So we'll read through. The function f of x is defined as f of x is equal to x to the power 3 minus 3x squared plus 4x minus 8. And it's saying there x is an element of R, so it can be any number. Again, fraction, whole number, decimal, whatever. Now it says find f prime x, the derivative of f of x. Now with differentiation, we're normally using y, and the derivative is dy dx, but in this case, we're using function notation. It says, hence, find the slope of the tangent to f of x at the point 2 minus 4. Okay, so the first thing we need to do is differentiate. Now we can do that by, well, my editing there is off. This is what this actual equation looks like. Okay, now the classic cubic equation would look something like this. Okay, and as the slope is changing, so it's increasing, then it stops increasing, 0, starts decreasing, stops decreasing, 0, and starts increasing again. Okay, so let me get rid of that text. Now, if I keep going on the editing here, now bear with me 1 second while I find the laser thing. So this is our original function. Now I'm going to differentiate each term separately. So the x to the power 3, the rule for differentiation is down here. We move the power down in front, and we take 1 away from the power. So we end up with 3 times x to the power of 3 take away 1. That's literally what this is saying. Very simple thing to do, okay? It's just to know when to do it. Now that ends up giving me 3 times 1 is 3. 3 take away 1 is 2. So I end up with 3x to the power 2. And the derivative of x to the power 3 is always 3x to the power 2. Like, you could memorize them off, but whose memory is that good? Now the second term here, plus 4x. Now what's actually going to happen is kind of weird, okay? Sorry, minus 3x squared. I'm multiplying the power by the number in front. So 2 by minus 3 gives me minus 6. Now my step 2 of this rule is to take 1 away from the power, and I've tried to illustrate that there. 2 take away 1 is 1, and we don't bother writing the 1 because by default, if there's no power mentioned, the power is 1. Now the plus 4x, a weird thing happens here. There is a 1 here. You're multiplying 1 by 4, and I've illustrated that there, and then you're taking 1 away from the power. Now that gives you a power of 0. Anything to the power of 0 is 1. So the x to the power of 0 turns into 1, and we end up with 4 times 1 is just 4. Now what we learn off is if you're differentiating at an x term on its own, the x just goes away. Or if you're differentiating a variable, the variable disappears, okay, if the power of the variable is 1. It's a kind of quick way of doing it. We don't need to be doing this extra work. Now, any number differentiated always turns to 0. And the argument would be that minus, I don't even have minus 8 on this graph. Let's pretend this line here, minus 6. What's the slope of that? There is no slope. So by default, any number differentiated always turns into 0. So this is my derivative. Okay, now they're asking me, find the slope of the tangent at the point 2 minus 4. Okay, now this here describes the slope. Okay, so we have our derivative, and I'm going to put in the x value, okay, in brackets, everywhere I see x, and then I'm going to put that through the calculator, and I ended up getting 4. So at 2, the slope of the graph is 4. Now, if you see it here, this is the actual curve, okay, where x is equal to 2 touches the graph. It is going up, and it's going up pretty fast. That's what a positive slope would indicate. If I got the negative answer here, it would mean that the slope is going down. And in the exam or whatever, you may not know that because you won't necessarily have time to graph this. It would take like 5 minutes, whatever. You don't really have time for that. I'm lucky in that I'm at a computer and I can just generate that actual graph. I can see that, yeah, it looks pretty legit. Okay, that's it. Again, slope seems like a useless concept, but we're surrounded by change. In science or engineering, if we can want to understand how that change happens, we can manipulate that change to build better electronics, better things, and make our lives better, hopefully. Now, part C here is more cognitive. Let's read through it because these can be tricky, but if you understand what slope is, this can be pretty handy. Okay, this g prime x means the slope is less than 0, the slope is 0, the slope is greater than 0. So what's happening at these 3 points is what the question is going on about. So it says the diagram below shows the graph of a generalized cubic function, g of x. P, Q, and R are points on the graph of g. Write each of the letters P, Q, and R in the correct place in the table so that each point matches the description of the derivative at that point, where g prime x, or the slope, is the derivative of g of x. Now, we have to give a reason then for part 2, but we'll worry about that in a second. Okay. Now, my first answer here is P. P is on top. The slope here is increasing, it's positive. Then it becomes negative. But when something changes from positive to negative, it has a slope of 0. This is the maximum point of that graph. And the trick when we're doing max and mins is to remember that at the max or min, the slope is 0. Now, the next one I've done out here is R. So this is where the slope is greater than 0. The slope is increasing. This is where the graph is going up. And then we're left with only one option, and that's Q, where the slope is less than 0, so it's negative. The slope is decreasing. So it's increasing, 0, decreasing, 0, increasing again. That's what's happening. Now, the reason is the g prime x means the slope. Okay, P is a maximum and the slope is 0. Q is a negative slope, so going down. R is a positive slope going up. Okay, there's lots of ways of stating that reason, but that's what I stated. Now let's the end of question 4. As always, if you want a copy of these notes, send an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.